Hello YouTube. In one hand, we have this. An RTX 5090 with a big crack problem. And in the other hand, we have this. Another RTX 5090, but this one has no core and VRAM. Today, we're going to cross our fingers and try to combine these ingredients. This will be the first time I'm trying to reball a 5090, so who knows what will happen. Right. First things first, I'm going to strip out this card and take a look at it under the microscope because I haven't inspected it yet. Trying to make sure the PCB is okay, there's no broken traces, there's no delamination or anything to worry about, and hopefully all the electrolytic caps are okay and not swollen. Let's get this apart. So, this PCB was bought, I think, from eBay, but it was only ever available because of China. So, I believe what's happening at the moment with 5090s is they are pulling the cores and the VRAM off, and they're fitting them to custom PCBs that allow a 2-slot cooler. This is because NVIDIA doesn't allow their board partners to make 2-slot coolers for their gaming graphics cards, because they don't want them competing with their professional series cards, which are much more expensive. Anyway, card is out of its heatsink. Let's take a look under the microscope. So, first, there's no damage on the PCIe retention clip. Good. We in focus. That's as good as we can, I think. Oh. Slightly knocked capacitors around the VRAM, which is to be expected. Doesn't appear to have any broken pads. Good. As far as I can see, none of the electrolytics are bulged, which is good. Because they don't really take care of these boards when they're removing the PCB and VRAM, so a lot of them will come with swollen capacitors that will need replacing, which just adds more work to the job. That all looks okay. Let's have a look around the power stages. A tiny bit of scratching up to this trace work. Is that a crack? Oh, don't tell me that's a crack. Zoom in. I think it's just a scratch. Just but a scratch. I think we're okay. But Q1011 is definitely seen better days. I think that's missing most of its important stuff there. You can see the leg coming into the main body here, and then just nothing. So yeah, that's had its time. We'll have to find something to replace that. Zoom back out. Connectors all look okay. All the power phases seem to look okay. What about the backside? PCIe looks good. Yeah, I think it's all okay other than that broken MOSFET, so that's good news. This might not be so bad. And if I look at it side on, I don't think it's too badly flexed either. We'll have to see when we go to put the core on, but I think this might be okay. I think this is quite a good PCB. I think we got lucky here. Right, okay. Here's the customer's original card. And it's missing its entire retention clip here. It was shipped inside a PC, and the card took a bit of an impact during shipping. The weight of the card meant the card is cracked, and some cracks can be repaired, but this one is a real mess. So, someone's already had a go at fixing this card. You can see several layers deep, and we're not even near the bottom of the crack. There's a couple of traces that have been patched up here, but it's a lot deeper. And then when you go to the other side of the PCB, the crack starts at the retention clip, and it just keeps going across the PCIe area, and even at this stage, the card is still cracked. So this crack is just too big to be reasonably fixable. Even if we can get this working, it probably won't last. So that's the reason we're going to swap the PCB. We're going to take all the good stuff, or hopefully good stuff, off this card and put it on the other PCB. So that's the core. I'm just going to, again, before I start, I just want to check the edges of the core are undamaged. Just clean the thermal paste off a second. Yeah, that looks okay. Cool. Okay, so let's get the thermal pads off. For the sake of my own sanity, I'm going to quickly measure rail resistances on all of these coils. I just want to make sure I don't introduce any shorts to the new board when I'm soldering it, and also make sure that this core doesn't have any short circuits before I begin. I don't really know the layout of 5090s, so I'm not really going to know if these resistances are good or bad, but what I can do is refer back to them later if we have any problems. So that's 3.5k, 8 ohms here, 275 ohms here, 31 there. Should we zoom you in a bit? So that's 31. Whatever this is, 0.26, 215 ohms. This is going to be 8 again, is memory 8 ohms. Hopefully that's okay. Up here, probably 12 volts input, 400 ohms. It's okay. Memory again. Yep. Don't know about these two. Memory, 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 which would suggest most of those large ones left are going to be core. That's 2.8k, just stop there. Alright, if these are core, these will be really low. 1.2, 1.2, 0.6. So I don't know what that 1.2 is. Maybe it's a different core rail. I don't know what power these use for the core. But that's measuring 700 milliohms or something. So that's quite normal. So the core should be okay. It doesn't seem to be shorted. Yeah, we've got a lot of 1.2 and 700 milliohms. As I say, I don't know if that's normal, but who cares? Let's pull that edge bonding off. And we're going to try remove this core and remove all the memory. Now, I don't have one of those sucky vacuum pens to remove the core, so I'm going to try and do it with tweezers, which is usually okay. I can usually do it just fine. But this core is quite a lot bigger and it looks quite a lot heavier than normal. So hopefully that goes okay. And then once the core's off, I'm going to go back around and pick off each of these memory chips. I think they're 16. 16 by 2 makes 32. So this has 16 2 gig chips. Anyway, none of that's really important. What's important is we get the core and memory off. Put the things in the things. There we go. We have the core and all 16 memory chips removed. I did have a little bit of trouble pulling the core off. One of the corners just wasn't quite as easy as the rest. It was maybe some uneven heating going on my rework station, but I managed to get it off, and it looks okay. It hasn't popcorned. I've not done any heat damage. It was okay. It was fine. But it is a little bit harder to remove one of these than it is, say, doing a 4090, just because it's so much bigger. Now, I think I'm going to approach this the same way I did when I upgraded the 4090, which is start by reballing the core, and then we can fit the core, check the PC recognizes the card, and then we can fit all the memory and hope for no memory errors. So to reball the core, I bought this. This is a XZZ stencil, or XZZ, I'm not sure. And the same sort of thing as you saw in my last video. We've got a magnetic base, stencil itself, and a template that just holds the chip nicely in place. So let's put that in there, and she fits perfect. Get the memory out of the way, and we can start working on reballing the core. So for flux, I'm going to be using a couple different fluxes on this card. I'm using M35 nano flux paste for my wicking and site cleaning. I quite like this for cleaning old residual solder because it's quite a thick flux and it stays in place, so it doesn't blur around or spread out, but it also doesn't burn too much. So I like this for cleaning. It's also very cheap. So that's what I'm going to be using here. And then when I come to fit the card, I'll be using Alpha Pop 707, which I quite like for fitting large BGAs, and it responds quite well to the solution in my ultrasonic cleaner, so I know I can clean up a card and make it look really nice without too much manual cleaning. Anyway, let's get going with getting this reballed. The same as always, we're going to add some leaded solder and some flux, clean up all the existing, and then we're going to bring in some wick and get those pads nice and flat. There we go. We've removed the old balls, and we are ready to fit the new ones. Now, in the 4090 upgrade video, someone commented that I shouldn't be spreading flux with my finger, so today we're using protection. And we will spread a thin layer of Solder King halogen-free tacky rework flux onto this, so it's ready for its new balls. That might be too much flux. Who knows? I've not done one of these before, so I don't know how much flux it wants. But that looks okay. I wonder how big the balls are. Let's get the thing on its magnet and add the stencil. Looks like this. Make sure it's in. Looks good. There's a bit of dirt in the hole though. I'm not sure what size these balls are. They look smaller than the 4090, so they could be 0.45s. Let's get some balls out, if I can find my balls. We can pour some balls on and see if they fit. Okay, we found our balls. Crisis averted. Is that enough? Who knows? People also mentioned in the last video I did a GPU that I'm very wasteful with my balls, so I'm gonna try and waste less this time. Not that they're particularly expensive. There we go. Let's switch over to the microscope and we can clean up the strays and fill any holes that aren't filled. I've got to somehow get all of these ones around the edge gone. So stencil seems good quality though, which is Gonna make this a lot less painful. Okay. And these holes could have maybe taken 0.5 mil. It's just a tiny bit bigger than 0.45. But I'll stick to 0.45, it should be okay. Sometimes using smaller balls can be beneficial because there's less chance of them shorting together if the PCB's flexed. Go in the hole. Damn it. Go in. Yeah. Yeah, okay. There's a cluster of missing balls in this top corner. My life would have been a lot easier if I'd done a better job of cleaning the flux off this template before I poured the balls on. You can see they're all sticking to the edge. That's because I didn't clean it properly. Because I'm too lazy. And now they're all sticky. And that is starting to get frustrating. Maybe if I zoomed in I'll have an easier time with this. That's a good idea. I don't know why I didn't think of that before. Oh my god, it's so much easier now. What a moron. I almost forgot I had a microscope there. Okay. Oh, there's more missing. I think that's the last one. Let's have a look. Oh, we've got some spares. I think there was a bit of dirt under one of them there, somewhere. I've lost it now, but it probably won't solder. We'll probably have to put that one on afterwards. Okay, I think we've managed to fill all the holes. So, oh, and some extras. Still. That was quite painful, but it was only because I didn't keep things clean. I'm definitely, probably gonna clean up better next time. So, let's set my temp, airflow. That might work. We shall see. And let's start reballing. I don't know if this stencil is going to flex at all. I've not used it before, so hopefully it's good quality. I quite like this brand. They usually make really good stencils, so I expect it'll probably be okay. Let's go a bit hotter. These chips have a lot of thermal mass, so to reball them direct heat can take a bit of time. Once the balls start melting, it's usually okay. Whoa. We have an extra ball there. Let's get rid of that. And we have a sneaky extra ball here as well. So, I'm just going to add a tiny bit of flux on top there. And pick that up with a soldering iron since it's already stuck. I'm going to have to try and remember where that is. And replace that ball, because it now won't be the same size as the rest of the balls. There's a couple in this corner that haven't flown into place very well, so I'm just going to hit them with a bit more flux and see what we can do about that. Give them a bit of a tap. Same here. There we go. Okay, I have a feeling I'm going to lose a few balls when I remove the stencil. They don't all look soldered, but they're close enough. Hopefully it won't be too many. So let's try and do this quickly because it's very hot. And just get rid of the balls on my desk and the old wick and all the junk. And we can pop that out. Oh, it's hot. And whoa, that shouldn't have dropped. Hopefully that's still okay. Don't drop your 5090 cores. That's a good lesson. The stencil came away way easier than I was expecting, but I guess it's because those holes are slightly bigger than the balls. Okay, let's see how we did. More light, less light. More light. There we go. Looking mostly okay. We've lost one there. Is that it? Did we only lose one? Ah, there's another one in the middle there. So let's add some of those back on. And we can try and track down the ones that's slightly smaller than the rest. Was it this one? I think it was this one. Let's put it at an angle, see if it looks any bigger. It's hard to tell, but it does have a sort of mark around it which suggests it could have been the one that I touched with a soldering iron. It's almost got thermal paste on it, which might have come off the tip of my soldering iron. Who knows? Let's just check the other corners. I know there's one of the corners, I know there's about 3 in. But they look okay. They all look okay. And they all look about uniform as well. So, my guess is one of those ones. But it actually doesn't look any bigger than the rest, so I might just leave it as it is. We can just add some liquid flux and give it a second pass like I usually do with my reballs. Watch all of the balls that aren't properly soldered drop into place. And then we can get to work prepping the PCB. I can't believe I dropped the core when I removed the stencil. Thankfully it wasn't from a large height, and thankfully I'd let it cool quite a bit before that happened, so I think it'll be fine, but sort of the last thing you want to happen when you're working on a chip that has a value of over £1,000 quite easily. I know the price of these are going up as well, so it's always a bit scary working on stuff this expensive. If you look closely, that ball there's not quite made it to the pad, so keep an eye on that in case it blows away. Whoa, where did you come from? I think that is okay. This reball's starting to look pretty nice. There are a lot of balls to look at with these cores. So it's a bit of a sensory overload trying to take in each one of these individual balls of solder, whether they've melted, whether they're the correct size, whether they've got any defects. Is that soldered properly? I think that one needs a bit more heat. You just see the edge of the pad there. Let's zoom you in. Looks like it wants a little bit more flux. Just a drop. We go again. Lovely. Perfect. Balls. If you can spot a missing ball, or you spot any defects, let me know in the comments below. Because this might not work. Who knows? Looks pretty good though. Cool. Ginormous core reballed. Ah, that's hot. That's burning hot. I'm gonna wait for that to cool down for a second before I lift it out of the way and put it to one side. Looks okay. No signs of heat stress or damage or anything like that. No chips on the edges. I'm gonna get this core ultrasonically cleaned, and so it's ready for the new PCB. Whilst that's happening, I can get the PCB prepped, remove all the residual solder, put this on, see what happens. Hopefully good things. But I think I deserve a cup of tea first. And we're back with the non-messed up PCB. So let's get the solder removed from this one. You should all know the drill by now. I'm going to add some flux. I'm going to add some leaded solder, mix it all in so we lower the melting temperature of the solder that's on the PCB, and then we can hit it with some wick and get those pads nice and flat. I'm going to change my iron tip out again. Normally I'd preheat the PCB, but I'm using a really big soldering iron today, so I don't think I really need to. This is the JBC T470 series iron, and it just overcomes thermal mass easily. This has really handled anything that I've thrown at it without doing any damage, without delaminating or demasking any pads. It's just a great iron, but it's a little expensive. JBC stuff always is. I'm also just going to go around each of the VRAMs to remove the residual solder as well. I'm not going to wick the VRAMs up yet, but I want to remove solder shorts so I can check resistances on this PCB before we fit the core, just in case we do have a shorted cap or something and we don't know about it. Add more flux. Okay, that should be okay for wick. We've got plenty of flux on there already. That's sizzling bad. I wonder why it's sizzling. Should just be flux on there. Maybe I should clean that off a little bit and apply fresh. Okay, we should be okay to clean this up and check it under the scope, see if we missed anything. Just soaking as much of the dry flux up with a sponge before I start to spread it out with IPA. I'm going to get as much off as possible. Though it's pretty sticky, so we're not going to get it all by any means. And we can use a clean room wipe and some alcohol to finish off the rest. Alright, it's very sticky. Okay, let's have a look under the microscope. See if we left any bumps. It's quite reflective. Let's turn the light down a little bit and zoom in. Maybe a couple around there. Feels flat. Still got a bit of residual flux on it. Okay, I think that's all good. Give it another quick clean up and we should be ready to fit the core. But I'm going to check some resistances first. So I want to make sure we don't have any shorts on 12 volts or anything else going on. Is there a bit of dirt that I can't get rid of up there? What's going on there? Just a tiny bit of dirt. Stubborn. I think there's still a couple that I've missed. Just there. Reflections are playing tricks on me. Well, that iron tip's too small. Okay, third time's the charm. This is clean now, I think. What I was meant to say is fourth time's the charm. I feel better about this now. Nice and clean, a nice flat surface ready for our chip. And let's get the multimeter out. Okay, so let's go red probe on ground. And here we have 40 ohms, which is the memory, I think. That's quite low for something with no hardware on it. That makes me a little nervous. What we got down here? 0.5k, 3k, 3k, 12 volt input, 3k. I think the 12 volt inputs are all okay, which is good. So the reason I'm doing this, okay, we have 3 ohms on core power. And despite the capacitors looking okay, I have a feeling some of them are bulged. Some of them are swollen or short circuit. Because we've got 2 ohms and there's nothing in circuit there. There's no GPU core, just the feedback lines in the DR MOS. So I don't think we're going to have an immediate success just by fitting this core. I think we will need to replace some more stuff. But I think for now I'm going to fit the core, power it up, and see what happens. So let's add some flux. Spread it with my nice protected finger. Get it all over the area. You don't want to put too much flux on, but you also need enough to ensure that all the balls get a good application of flux. This flux here, the Alpha Pop 707, is pretty well behaved if you over apply, so I'm not so worried. Okay, we're back, and we have the core on. Now, there are 2 things that I did off camera when I tried to fit the core. The first thing I came across was I ultrasonic cleaned the core, just to get the flux off the back of it, ready to fit, and I did go back over it under the microscope. I checked for any defect balls, and I did find a couple of balls that I wasn't really happy with, so I replaced a couple solder balls on the back of the chip, made sure I was totally happy with all the balls. And then, when I came to fit the core onto the PCB, I noticed if I tap a corner, there was a wobble. Now, earlier in the video I said that there was the board looked good. There wasn't really any major signs of flex, but I was wrong. This board was quite flexed. So with a flex board, it can be quite hard to solder a core. You'll end up with one corner further away, or shorts in one corner if the corner's too close to the core. Now, to fix this, I literally just wrenched on the PCB until it felt like it was in the right spot, put the core back on, gave it a tap, tested it, and just kept working on it bit by bit, trying to twist the card and get the card flat again. Now, this is not something I'd recommend you do to a PCB. So for the sake of getting this PCB straight, I could have tried to use weights and a bit of heat to try and straighten it out, but that would have taken some time, and I'm a bit lazy. Also, I wouldn't have known if I got it right, so I might have to do that several times before I'm happy with fitting the core. Now, twisting a PCB is not a good idea because you can introduce loads of cracked solder joints and you can introduce other problems, but we have a lot of other problems with this card, so I think twisting it back into shape is going to be the least of our worries right now. Anyway, the core's on, the core's soldered. I'm just going to recheck resistances. Now we know with the core off we had a low resistance on core and memory, so we probably got some bad caps across here and some bad caps around the memory output. Probably the closest ones to the core have received the most heat, and therefore that's the most likely ones that will be bad. But hopefully the power supply will overcome that. We just might see some of these capacitors getting hot, or might see some strange issues with no detect or something like that. But for now, let's just quickly check all of the resistances as they are. So memory's down at 16 ohms. Not sure. Whatever that is 1.5 ohms. And the core rail is where we'd expect it. I mean, it's slightly high, but I think that's just my probes being a bit weird. Yeah, my probes are messing me about a bit. 900 milliohms, 800 milliohms, something like that. What about here? That's okay. That's memory again. The input, the 12 volt is okay, which is good, and then these will be core again. So no need to worry about those. And that's not short either. Perfect. Now I'm gonna, so if you remember before, we noticed a bad component that been knocked off over here. So I found something that will work in place of that from a donut. It has the same marking, it's the same type of component, so we should be okay there. I'm going to quickly fit that, and then we're going to try and power this up on my bench supply. One of two things are going to happen. Well, one of three. It's either not going to work because it's broken, or it's not going to work because my power supply is only 6 amps, and I've heard that these 5090s take a bit more than 6 amps on startup, so they'll have high current spikes. So this might not actually have enough power from my bench supply. My bench power supply is limited to 6 amps, and so if I plug it in and it doesn't work, I'm not going to worry too much. I'm going to try it in a PC afterwards and see what happens. But for now, I'm going to fit the broken component. I'm going to try and power it off my bench supply, and if that doesn't work, we can plug it into a PC and see what it does. Get rid of the remnants of the old legs. I don't have a schematic for this card, so I don't actually know what this component does. Right, let's get it plugged into a riser. As I say, I really have suspicions that this is not going to work because my bench power supply is not enough to power this card. But we can try, why not? It's not going to do any harm. Let's plug that into my bench supply. And it's set to 12 volts, 6 amps. Let's turn it on and see what happens. Oh, is it actually turning on? It is drawing 5 amps. 4, 5. It's doing something. Right, okay, it's more than I was expecting. I suppose I should probably find a heatsink to put on top of the core, and we can check if the rails are showing up. I did not expect that to power up. That's good. That's really good, because now we can see possibly if we've got any capacitors that are getting hot. See if that low resistance problem is caused by damaged capacitors. Okay, let's turn it on again and check our rails. So we have 1.2 on memory, which is good. We have 0.8. 0.9, I don't know what the core rails are meant to be for a 5090, but things are looking good. 1.2 on memory is good. So up here, 1.8, that's good. 5 volts. This is going to be 12 volt input, right? 10, okay. Struggling a little bit with power. What are you? 0.8, good. Yeah, I think the card's powering up, so I guess the next stage is to turn it all back off, and we can actually, let's hit it with a thermal camera, see if we've got any hot spots around any capacitors. But this is more than I expected. So far, so good. Right, okay, let's turn it back on. Come in with the thermal camera. So we've got a bit of heat on the right hand side down here somewhere. A bit of heat down here. A bit down there. Basically all around the coils. The phases are getting hot. That central one is getting a little hotter. But I can't see any of the caps getting hot. So it's weird that the board had such low resistance. It's weird that the board had such low resistance before I put the core on, to be honest, because there wasn't that much in circuit for it to have low resistance. But I don't know. It seems okay. It seems okay. So let's turn it off and put it in a PC. See if it shows up in Device Manager. This is going way better than I expected. Awesome. Now, if this does show up, it's obviously going to have driver errors because it's got absolutely no memory. But PCIe should work, so it should at least recognize a device. I'm going to quickly pop the clamp around the center of the heatsink, which should be enough just to test it. And then if this shows up, I guess we can just get on and reball all the memory, fit that, and see if we end up with any memory errors. There is a chance that there's like a missing ball or a bridge under the core somewhere. I could fit the memory and still have memory errors. The core might still need to come back off. But the fact that the card powers up is a good sign. Means that the card is mostly working.
This video is getting pretty long, so I'm going to have to split it into 2 parts. Join me in part 2 to find out if the core survived, or if we've just been wasting our time.